Multiplying polynomials. There are a number of different situations multiplying polynomials. We're going to start with one that you may have seen sometime earlier in your math career, which would be something like this, 4x to the third, and we're going to multiply that by 6x squared. So these are polynomials. In fact, they are monomials. A monomial is a number, a variable, or the product of numbers and variables where the variables have whole number exponents. So this is an extension of simplifying powers. I'm just going to rewrite this, put in the numbers next to each other, and then the powers next to each other. And then we can just do some arithmetic here. 4 times 6, that's 24. And reminding ourselves of the properties of powers, a to the m times a to the n is a to the m plus n. So I have x to the 3 plus 2. That gives me 24x to the 5th. Voila! Let's try another one. Let's try something a little bit bigger. 2a squared b, that is our first monomial. We'll multiply that by our second monomial, 5b to the 5th. I'm going to rewrite it just to simplify things so I don't lose track of what I'm doing. 2 times 5, those are the number parts here, times I have a squared. I don't have any other powers with the same base of a squared, so I'll leave that by itself. And I have 2 powers with a base of b. b times b to the 5th. Well, 2 times 5 is 10. A squared, there are no other powers with a base of a, so I just have my a squared. B, that's b to the first, so b to the first times b to the 5th makes it b to the 6th. Sometimes you get 3 monomials. How about 1/2 x squared y? We'll multiply that by 8x to the third z squared, and then a third monomial, y to the 4th z to the 5th. So I could rewrite it, putting all the numbers together, all the powers with the same base together. I'm going to try this in one fell swoop. I've got 1/2, I've got 8. 1/2 times 8, yes, that is 4. Now I will look at the powers with the base of x. X squared, x to the third. X squared times x to the third, 2 plus 3 is 5, so that gives me x to the 5th. Let's look for the powers with a base of y. I've got y and y to the 4th. Remember, that's y to the 1st, so y to the 1st times y to the 4th is y to the 5th. And then I've got a couple powers with a base of z. So I will have z squared times z to the 5th is z to the 7th. And that is monomials times monomials. Remember, a monomial is a polynomial, even though it only has a single term. The next step is a monomial times a polynomial. And this time our polynomials will have more than one term. So a fairly simple example would be something like 3 times 4x squared plus x minus 5. This is just an extension of the distributive property. We're going to use the 3 outside the parentheses and multiply it by each of the terms inside the parentheses. We can rewrite this as 3 times 4x squared plus 3 times x minus 3 times 5. Then we simplify these terms. 3 times 4x squared. 3 times 4 is 12, so I end up with 12x squared. Here it's just 3 times x, which is 3x. And here it's just 3 times 5, or negative 3 times 5. Negative 15. That's it for that. It's just a distributive property with a couple extra steps. But they can get a little more complicated pretty quickly. If I have 2x squared y times 6x minus y, I've got to deal with a few more variables here. Well, one more variable at least. taking this whole 2x squared y, multiplying it by each of the terms in the parentheses. That will give me 2x squared y times 6x minus 2x squared y times y. 2 times 6 is 12. X squared times x is x to the third. And I only have one power with a base of y, so I just have my y. Over here, minus 2, I have a power x squared, no other powers with a base of x, so that's x squared. And y times y, that's y squared. Let's look at one more. Let's do 5a times a squared b plus 3b squared minus 4. I'm going to try to do this without writing this middle step where I show all of the terms multiplied. Sometimes that can make things a little more confusing. I'm just going to go straight to the final step. 5a times a squared b. There are no other numbers, so it's just 5 as the coefficient. A times a squared. That's a to the third. And 5a, there's no b in that term, so I'm just taking the b from the next term. Plus, 5 times 3 is 15. I have an a and a b squared, so there's no a in the middle term in a power, and there's no b in the outside term, so it's just 15ab squared. And then finally, 5a times negative 4, negative 20a. So I hope what you're noticing is that multiplying a monomial times a polynomial, no matter how many terms it has, is just an extension of the distributive property, and it uses the properties of powers, multiplying powers with the same base. We multiply powers with the same base, add the exponents.